Yesterday, we had some problems on trig identities, and the problems were done with trig identities. That was the intent of the problem, but there are more efficient ways to answer these specific questions. The reason I'm like, I'll use trig identities is because that was the subject, that we want to recognize how the trig functions are all related to each other. We want to know that all these trig functions are related to each other. Just be happy that we're only using these 6 and not like the 11 or 12, or there's a whole bunch more. We have calculators now, so we don't need very many. So the problem setup was, I told you the cosine of an angle was -0.8, for example. Then I included the information, theta is in quadrant 3. The reason that I had to include that information is that that first statement is not specific enough. When I say cosine of theta is -0.8, there are 2 thetas that fit that description. I want the one in quadrant 3. So the reason I have this, this part of the statement says, this refers to 2 different angles. One in quadrant 2 and one in quadrant 3. Cosine is negative in quadrant 2 and quadrant 3. So when I say cosine of theta is -0.8, that refers to 2 different angles. So I say, I want the one in quadrant 3. So that's why for some of these, I had to tell you what quadrant we were in. I didn't have to do that for the first 2 because the first 2 just used reciprocal identities. And if sine is positive, then its reciprocal is also positive. The sign of a number will always match its reciprocal. I didn't have to say that for the first 2. Since we're in quadrant 3, what that tells us is that sine of theta is going to get a negative value. And tangent will be positive. The sine is negative in the 3rd quadrant, and tangent is positive in the 3rd quadrant. So the standard operating procedure for Tuesday was to look at this information and use an identity. So use the cosine squared plus sine squared equals 1 to get the sine. I'm just going to write it out. Cosine squared theta plus sine squared theta is equal to 1. And I'm going to plug in -0.8. And then I could use this to solve for the sine of theta. So if the 0.8 squared is 0.64, because 8 squared is 64, but then I have to multiply, I take a 0.1 times another 0.1, that's 2 0.1s or 2 decimal places. Then I'll subtract 0.64 from both sides. And 1 minus 0.64, think of 100 minus 64 and get 36. But this was in cents, so 0.36. This is where we're going to need our plus or minus. We have to make a choice, because if sine squared of theta is 0.36, then sine is plus or minus the square root of 0.36. In this case, this is the square root of 36 over 100. Because 100 is just 10 squared, I can do the square root of 0.36 is just 0.6. 0.6. Since theta is in quadrant 3, I'm going to choose negative. That was the idea behind this problem. I also wanted to see who would look at 0.8 and square it without using the calculator. Who would subtract the 64 from 100 without using a calculator, and who would square root 36. Now, we can't always just do this. This worked out because we were taking the square roots, and there were two. It was a 10 squared in the denominator. 0.36 is 36 over 100. So the square root of 36 is 6. The square root of 100 is 10. So that's the way. That's the reason that that worked out. So that's the reason, because it was the square root of 100, because it was a 1 over 100 point, 2 decimal places with the 36. Square root of 36 is 6. Square root of 100 is 10. So there's the 0.6. If we had something else, if it was something over 1,000, like 0.036, now we're kind of messed up because there's not a nice square root of 1,000. Because 1,000 is 10 to the third. And when I square root it, a square root is a 1/2 power. So this works out because it was the square root of 10 squared. This works out because there are 2 decimal places. Any questions? A square root is a 1/2 power. So about the square root of 10 squared is 10 squared to the 1/2 power, or 10 to the first. Okay. How many of you read square roots as 1/2 power? Did anybody? That might be a new thing. That one's hard because it's usually about 50-50. You got to be careful when you ask questions in a math class. Like let me give you have to ask anti-questions is what it boils down to. Because, well, it kind of comes down to this. We are all, not me, like y'all are too cool to be like raising your hand in class. So if I ask something like, raise your hand if you know what 2 + 3 is equal to. See? But I know that y'all know what 2 + 3 is equal to. But if I do the anti-question, raise your hand if you don't know what 2 + 3 is equal to. See, everybody knows. Yes, the anti-question. That way you don't have to engage in like a public speaking type of thing, which is everybody's like #1 fear. Not everybody, it's like most people's #1 fear is like public speaking, standing up in front of an audience and having to talk to them. It's true for me too. I do not like public speaking. Now you might think, it's like, oh, well, your job is public speaking. Like, well, not really. Because I have a captive audience. Stuck here, you all. Not physically restrained. Y'all can get up and walk out anytime. And you know that I won't say anything. Like in high school, you try that, and she's like, oh, where are you going? We've got a runner in 7104. concrete from running out like this because they're more aerodynamic. I think it's because he's a robot. Anyway, so the reason that this worked out, that it was so easy to find the square root of 0.36 is that we're reading 0.36 as 36 over 100, and both of those are squares. This is why I picked 0.8 in the first place, because I knew that this would work out. Now, at the other part of the question was find tangent of theta. At this point, we have more information. At this point, we have more information. I'll not only have cosine is negative 0.8, I also have that sine is negative 0.6. So when I go to find tangent, if I want to find tangent of theta, I can take the cosine of theta and divide by the sine of theta. Cosine of theta is negative 0.8. That's what we were given. Sine of theta, we now know, is negative 0.6. The negatives cancel out, give us a positive. We expected that because theta is in quadrant 3 and tangent is, I wrote cosine over sine. Thank you. Tangent is sine over cosine. So cosine is negative 0.8. Sine, we now know, is negative 0.6. We don't have to worry about the plus or minus because I'm not doing that square root stuff. We've already made that decision. When we calculate tangent, the negatives are going to cancel out and be positive. And we're like, oh, yeah, we're okay with that because tangent is positive in the third quadrant. And 0.6 divided by 0.8 is 6 over 8 or 3 over 4. Since these are all in decimals, the 3/4 is going to feel really weird walking in dressed as a fraction. So maybe we convert this to 0.75. Or maybe tangent walks in as 3/4 and the 0.6 and the 0.8 are like, oh, wow, that fraction, that is cool. And 0.8 is like, oh, I'm 4/5 now. And then sine's like, well, I don't want to be left out. I'm 3/5 now. I don't know. I don't know what it's like. I don't know what peer pressure is like with trigonometric functions. I also don't pay attention to fashion trends and stuff like that. So. Any questions? This was the intended method to do on Tuesday because I was like, oh, hey, all these trig functions are related. Here's how they are related. Here's one of the ways they are related. Trigonometric identities. Any questions? Comments? Any comments? The reason I point out this square root of 0.36 thing is we got to be careful. We don't want to fall into certain patterns. So like if I write, so we got to be careful. If I wanted something like the square root of 0.144, we might look at this 0.144 and see that's 12 squared. But the problem here is the denominator. This is 144 thousandths, not 144 hundredths. All right, so this fraction is 144, and we're like, oh, that's a good square root. That's a 12. But the denominator is not. It's not a square. The denominator is 1,000. And the 1,000 is not a square. 144 is a nice square. Thousand is not a square. Wait, that would better. Not a square. It's like 31.6. Any questions? We got to be careful with our power. And the reason that this doesn't work out is that 1,000 is 10 to the third power, not 10 to the second power. So what we're looking at with this square root of 1,000 is a 10 to the 3/2 power. Any questions? Is everybody okay? Everybody remember their algebra? There's not a quiz on this today, so you can be like, oh, yeah, totally. Radicals are fraction exponents. This one's gonna be okay. This one's still not okay. We have calculating machines, so we can find this out. All right, this one's gonna be okay. Why is this one okay? I said the opposite of what I wanted to say. Why is this one okay? What is it? Why are they both square rootable? What did I change? In this one, I had 3 decimal places, which is dividing by 1,000. How many decimal places here? 2. So we're dividing by 100. So that one works out. Any questions? How's everybody okay? Yes. If we wanted to rationalize the square root of 1,000. Good question. So if we wanted to rationalize this 12 over the square root of 1,000. One thing we could do is just multiply by the radical we see in the denominator. I can multiply by the square root of 1,000 over the square root of 1,000. And that'll give us 12 times the square root of 1,000 divided by 1,000. This is still a little bit excessive. The 12 and the 1,000 have something in common. So this is not simplified. So this is not simplified, but it is rationalized. So that 12 root 1,000 over 1,000 is not simplified, but it is rationalized. So we can see that they are the same value. I know it keeps moving around. I'm Blair witching you all. There, hold still. Too much coffee. So that's not simplified, but it is rationalized. If we wanted to simplify it, we'd have to get the 12 and the 1,000 and cancel any common factors. We have to simplify 12 over 1,000. So we can pull a 2 out of that. Oh, we could have pulled a 4. 6 divided by 2 is 3. 500 divided by 2 is 250. You don't have to get the biggest thing right away. So this is 3 roots of 1,000 divided by 250. 3 times the square root of 1,000 divided by 250. Ah, good, it's the same. But this is still not simplified because the square root of 1,000 is not simplified. 1,000 has a square as a factor. The 1,000 has a square as a factor. So if there's a square as a factor, I can find the square root of that square. I can simplify some more. So this is going to be 3. Because 1,000 is 1,000 is just 100 times 10. And I can simplify the square root of 100 as just 10. This is still not simplified because now the constant have the 10 and the 250 have something in common. We can cancel that out. And so a simplified form of this would be 3 times the square root of 10 over 25. That's how you would rationalize and simplify this. So 3 square root of 10 divided by 25. I spelled 25 wrong. Is still the 0.379. Any questions? If you left this as 12 over the square root of 1,000, I'd be happy with that. If you wanted to flex and show off your mad algebra skills and write 3 root 10 over 25, also okay. Keep in mind, dangerous to do. If I'm going to accept 12 over the square root of 1,000, that's the safest answer. If you start doing more stuff, you start increasing the chance that you're going to do something wrong. And so you'd be like, oh, 3 square root of 10 over 50. And now there's a problem. And I take off 1,000,000 points. And in either case, we're getting information. Any questions, comments, deep thoughts? How's everybody okay? We look so serious today. You all look like this. Why so serious? So the point, the process that we did on Tuesday is not because we didn't do it that way because that's the most efficient way to do it. We need to, first of all, get rid of that idea. Like the way that we do things in math, the goal is to like do things quickly. Because if we wanted to do things quickly, cosine of theta is negative 0.8. Let's just figure out what the friggin' angle is. It's a 36.8 degree angle in the third quadrant. So it's a 216.8 degree angle. Now I want the sine of this angle. If the goal is to do things quickly, use the machine to do things quickly, right? That's the other reason I wanted to do all these calculations just by doing the calculations. Because, I mean, if I'm going to start using a calculator for this, just use a calculator on the whole problem. The point is that the trig functions are all related. That's the point of the exercises that we did. And also to find out how awesome your algebra skills are. How's everybody okay? Plus, I mean, you wanted to be reminded of algebra because it's like your favorite math class so far, right? I mean, until trig comes along, you're like, oh man, I wish I could do some more algebra. And then on Tuesday, I was like, oh, here you go, some more algebra for you to do. And you're like, oh, yay, more algebra. I don't know if that really happened or if I just made that up in my mind and hallucinated the whole thing, but that's the story I'm going with. And my colleagues asked, what did they think of that algebra stuff with the trig identities? And my colleagues, they fucking loved it. They were so stoked. Because I looked in your room and they looked like they were all sad and bored. All incorrect. Stoked, happy. And they're like, oh, Leach, are you high? I'm like, oh, not right now. 20 minutes, check back. I'm just kidding. I am high right now. I'm just kidding. 20 minutes. I'm just kidding. Oh, great. I recorded that. That was the point. Trig functions are related. Let's think of an alternate way. So cosine of theta was negative 0.8. And theta is in quadrant 3. Look at us using our fancy notation already. Although my theta kind of got Q. I got Q on my theta. Conspiracy theorist theta. Same question. So no, we know the answers. Negative 0.634 or 0.75. It's all be decimal. We also want to do this problem with our unit circle approach. We want to think about what's going on the unit circle. So we're going to go after this problem unit circle style. So if I draw a set of axes, I'm going to say this cosine of theta is negative 0.8. I'm going to read that as the x coordinate on the unit circle. So I'm going to read cosine as x. So I'm going to draw a negative 0.8 on the x in the third quadrant. And I'm going to draw and intersect that with the unit circle. And I'm going to draw the reference angle in the third quadrant. So there's my x equals negative 0.8 in the third quadrant. On the unit circle, the hypotenuse is 1. The radius of the unit circle is 1. That's where the hypotenuse is going to go. So if I've got one side is negative 0.8 or 0.8, and the other side is the y, we can use the Pythagorean theorem to figure out y. So we can just use this in the Pythagorean theorem. There are two triangles I could have drawn here in the second quadrant and the third quadrant with an x of negative 0.8. Since we were told it was in the third quadrant, that's why I picked the one under the x-axis. And then we could just solve this, and this is going to look familiar. 0.64 plus y squared is equal to 1. So y squared is equal to 1 minus 64, or 0.36. And so y is equal to plus or minus 0.6. And since we're in the third quadrant, y is negative 0.6 in quadrant 3. So what we're doing is we're finding the coordinates of the point on the unit circle where we have an x coordinate of negative 0.8 in the third quadrant. The coordinates of this point. The cosine of the x coordinate is negative 0.8, and the y coordinate is negative 0.6. Notice that the trig identity that was in play was the same trig identity that was in play in the previous problem, or in the previous working of this problem. Cosine squared plus sine squared is equal to 1. That's what we wrote down here. Cosine squared plus sine squared is equal to 1. Because in this unit circle style, sine is y. If we want tangent, the same thing happens. We take sine over cosine, 0.8, 0.6 over 0.8, 3/4. So this trig identity approach is the same as if we use this coordinate approach, and it's the same as if we had used a right triangle. The right triangle that we're pulling out here when we write cosine this is the right triangle approach. When I write cosine of theta is negative 0.8, this is adjacent over hypotenuse. So if I read negative 0.8 as negative 0.8 over 1, I'll put an adjacent of negative 0.8. and a hypotenuse of 1. Then I use the same Pythagorean theorem to get the opposite. It's weird to draw a triangle and say this side is negative 0.8. But it still works out the same way. That opposite would be a negative because we're thinking in terms of standard position of force. Was that okay? No, that was my problem. All right, let's take a break, come back, and then we'll practice this strategy on some different problems.